this video, we are going to learn about how to calculate heat balance sheet for IC engine. The performance of engine is given by heat balance sheet, and it is used to know account of heat supplied and heat distributed. The heat balance sheet is done on second basis or minute basis or an hourly basis. Heat supplied has only one value, and that is heat supplied by combustion of fuel, which covers whole 100% of heat supplied, and that is given by QS is equal to MF into CV, where MF is the mass of fuel supplied per minute or per second, where CV is the calorific value of fuel. Here utilized column has 4 values. Those are heat converted in brake power, heat carried away by cooling water, and heat carried away by exhaust gases. And the rest of heat is unaccounted heat. That part of heat is lost by convection and radiation, as well as due to leakage of gases. These 4 together meets to form 100% of utilized heat. So first is heat equivalent to brake power of engine, that is QBP in kilowatt or kilojoule per second or kilojoule per minute. Now second is heat carried away by cooling water, that is QW is equal to CPW into MW into TW minus TWI, where TWI is the percentage of cooling water at inlet in degrees Celsius, and TW is the temperature of cooling water at outlet of engine in degrees Celsius, and MW is the mass of cooling water in kg per minute or kg per second circulated through cooling jacket, and CPW is the specific heat of water in kilojoule per kg Kelvin. Heat carried away by exhaust gases, that is QG is equal to mg into CPG into Tg minus Tr, where mg is the mass of exhaust gases in kg per minute or kg per second, where Tg is temperature of burn gases coming out of engine, Tr is the room temperature in degrees Celsius, and CPG is the specific heat of exhaust gases in kilojoule per kg Kelvin. And part of heat is lost by convection and radiation, as well as due to leakage of gases. Here part of power developed inside the engine is also used to run accessories such as lubricating pump, camshaft, and water circulating pump. These heat are cannot measured precisely, and so that this part of heat is known as unaccounted heat. Unaccounted heat energy is calculated by difference between heat supplied and sum of heat converted in brake power, heat carried away by cooling water, and heat carried away by exhaust gases. Now we have the values of heat supplied and heat utilized by the engine. From these values, we have to prepare balance sheet. The result of different values of heat supplied and heat utilized are tabulated in table, and this table is known as heat balance sheet. This table also has percentage representation of heat supplied and heat utilized. Now we'll draw heat balance sheet for given problem. And the statement is an IC engine uses 6 kg of fuel having calorific value 44,000 kilojoule per kg in 1 hour, and the brake power developed is 18 kilowatt. The temperature of 11.5 kg of cooling water found to rise through 25 degrees Celsius per minute. The temperature of 4.2 kg of exhaust gas with specific heat 1 kilojoule per kg Kelvin was found to rise through 220 degrees Celsius. Draw heat balance sheet for the engine. Here first we'll write down the given data, that is mass of fuel is equal to 6 kg per hour, which is 0.1 in kg per minute, where brake power is equal to 18 kilowatt, and calorific value, that is CV, is equal to 44,000 kilojoule per kg. Mass of cooling water MW is equal to 11.5 kg per minute, and specific heat of water, that is CPW, is equal to 4.187 kilojoule per kg Kelvin. Temperature rise of cooling water TWO minus TWI is equal to 25 degrees Celsius, and the mass of exhaust gases, that is MEG, is equal to 4.2 kg per hour, which is 0.7 in kg per minute, and temperature rise of exhaust gases, that is TG minus TR, is 220 degrees Celsius, and specific heat of exhaust gases CPG is 1 kilojoule per kg Kelvin. Now here first to calculate heat supplied by combustion of fuel, that is QS, which is equal to MF into CV, where mass of fuel MF is 0.1 kg per minute and calorific value, that is CV, is 44,000 kilojoule per kg. So put these values and we'll get QS. Now to calculate heat converted in brake power, that is QBP, is 18 kilowatt, which is equal to 1080 in kg per minute. And to calculate heat carried away by cooling water, that is QW is equal to CPW into MW into TWO minus TWI. Now put this value of CPW is 4.187 kJ per kg Kelvin and mass of cooling water MW that is 11.5 kg per minute and temperature rise of cooling water that is TWO minus TWI is 25 degrees Celsius, and we'll get value of heat carried away by cooling water that is QW is equal to 1203.76 kg per minute. Now to calculate heat carried away by exhaust gases that is QG, so put the value of mg that is mass of exhaust gases into CPG that is specific heat of exhaust gases and temperature rise of exhaust gases that is Tg minus Tr, and we'll get value of heat carried away by exhaust gases that is Qg is equal to 154 kg per minute. Now to calculate unaccounted heat, we'll subtract sum of heat converted in brake power, heat carried away by cooling water and heat carried away by exhaust gases from heat supplied by combustion of fuel. So here unaccounted heat we got as 1962.24 kg per minute. Now we have the values of heat supplied and heat utilized by the engine. From these values, we have to prepare balance sheet. The result of different values of heat supplied and heat utilized are tabulated in table, and this table is known as heat balance sheet. And the table also has percentage representation of heat supplied and heat utilized.